Okay, so this is a key to section 1.4, part 1. Now, in the first part, you are going to be um, adding and multiplying complex numbers, it looks like, and subtracting. Now, you do want to write the answer in standard form. So remember, standard form in terms of complex numbers is a plus bi. So make sure it's in that form. Okay, so in the first one, you're just adding these two complex numbers. So basically you're saying 9 plus a negative 2 is 7, and then 3i plus a negative 8i is a negative 5i. So you're adding the real number parts, remember your real number parts, 9 and negative 2, and you're adding the imaginary parts, 3i and a negative 8i is a negative 5i. Okay, number 2, and I'm going to go ahead and actually put this, do the work here for number 2 and the rest of these. So number 2, you have 6 minus 2i, subtract 3 minus 9i. And so what you want to do is actually, there are several ways to do this. You can think of this as adding the opposite, or you can just multiply through by a negative 1, since that's understood to be a 1 right here. So basically you're going to say 6 minus 2i, a negative 1 times 3 is a negative 3, a negative 1 times a negative 9i is a positive 9i. So you're going to add the real number parts, so you can say 6 and a negative 3 is a positive 3, and then negative 2i and a positive 9i is a positive 7i. So that's number 2. Number 2 is 3 plus 7i. Make sure it's in standard form, a plus bi. Okay, number 6, you have this. You have this in number 6. You have, I need number 6, number 3. You have 6i plus 4 plus 2i. Now that one's easy because it's in that you're adding two complex numbers. So basically you're adding the real part. There's only one real part, so that's 4. And then you're adding the imaginary part. 6 plus 2i is 8i. So that's number 3. So 4 plus 8i. Okay, number 4 looks like this. That's number 4. You have 16 subtract 13, 16i rather, 16i, subtract 13 minus 4i. So just like we did number 2, think of this as being multiplied by negative 1, or you can just have said adding the opposite, because that's what subtracting is. Subtracting is adding the opposite. So you would say 16i plus the negative 13i plus 4i. But you could have distributed negative 1 just as well, and so you would have gotten 16. Negative 1 times 13 is a negative 13. Negative 1 times a negative 4i is a positive 4i. And then all you do now is add your real parts. So 16 and a negative 13 is a positive 3, and then plus 4i. And that's all you have. So the 16 plus 4i. I'm sorry, 3 plus 4i is number 4. Okay, number 5, you have this. You have 2i times 3i plus 4. Okay, so now you're multiplying a complex number by another complex number, but this is just an imaginary part here. So you're going to distribute. So distribute the positive 2i. So basically you have this. You have 2i times 3i. So if you need to write this out, you write this out. Try not to do too much in your head when you're multiplying imaginary numbers. And then 2i times 4, so you have 2i times 4. So basically the first thing I did was I just wrote out what I was doing. So 2i times 3i, and then 2i times 4. Now let's go ahead and deal with this part first. 2 times 3 is 6. I times I is I squared. Plus 2 times 4 is 8, and 8 times I is 8i. So that's what I have at this point. So again, 2 times 3 is 6, I times I is I squared. Now I have to remember this. I have to remember that I squared is equal to a negative 1. You learned why that's true in a previous lesson. So we have to know that I squared equals negative 1. So if I get an I squared anywhere around here, I got to remember that that is a negative 1. So this becomes 6 times a negative 1 plus 8i. And 6 times a negative 1 is a negative 6 plus 8i. And so there's your answer. You have it in the form a plus bi. So negative 6 plus 8i. So negative 6 plus 8i. Okay, number 6, you have negative 7i times 4i minus 3. So same idea as this one. You're multiplying a monomial times its binomial, so you can use the distributive property. Okay, so it's a good idea to write in these steps though. So negative 7i times 4i plus a negative 7i times a negative 3. That's what you have. Negative 7i times a negative 3. Okay, over here, negative 7 times 4 is a negative 28. I times I is I squared. Then over here, a negative 7 times a negative 3 is a positive 21 times I. So that's what I end up with there. Now again, I got to remember that I squared equals a negative 1. So this right here, I got to rewrite. So this becomes a negative 28 times a negative 1 plus 21i. And so a negative 28 times a negative 1 is a positive 28 plus 21i. And so there's your answer. So 28 plus 21i is number 6. 28 plus 21i. Okay, number 7. Number 7 looks like this. Number 7, you have 6 minus 5i times 3 minus 2i. So 6 minus 5i times 3 minus 2i. So notice that in numbers 5 and 6, since notice that this was a binomial and this was a monomial, so I just distributed. I used the distributive property. Here, though, it's two binomials, so I have to use the FOIL method. So you have to use the FOIL method. So 6 times 3 is 18. That one's easy to do in your head. The outer, to the outside terms, again, that one's easy to do in your head as well. 6 times a negative 2i is a negative 12i. The inner, the inside terms, a negative 5i times a positive 3 is a negative 15i. And then the next one, first of all, let's think about the last now. You got to be careful with the last. A negative times a negative is a positive. 5 times 2 is 10. I times I is I squared. That's what you have. So a negative 5 times a negative 2 is a positive 10. I times I is I squared. Okay, so again, using the fact that I squared equals negative 1, so I'm going to circle this to remind me about that. And we also know that we can combine these two terms, the outer and the inner. So I get 18, a negative 12i, and a negative 15i is a negative 27i. And then I get plus 10 times a negative 1. Okay, so let's deal with this 10 times negative 1. So I get 18 minus 27i. Positive 10 times a negative 1 is a negative 10. Combining like terms, 18 and a negative 10, I get 8 minus 27i. So that's number 7. So 8 minus 27i. Okay, number 8. Number 8 here. Okay, number 8, I have 5 plus 2i times 5 minus 2i. So again, I'm multiplying two binomials. I'm going to use the FOIL method. 5 times 5 is 25. The outer is a 5 times negative 2i is a negative 10i. The inner, a positive 2i times 5 is a positive 10i. And then the last. So I have positive 2 times a negative 2 is a negative 4. I times I is I squared. So again, make sure you get a negative 4i squared. A positive times a negative is a negative. 2 times 2 is 4. I times I is I squared. Okay, now I've got to use the fact that I squared is negative 1 just like I did this one. So I'm going to circle it to remind me about that. And I can combine these two. Now I want you to notice that the out and the inner cancel out here. I get 0. And make sure you understand why. See how the first terms were alike and the last terms were opposites of each other? Then it's going to happen where the outer and the inner will just be opposite terms. So they're going to cancel when you add them up. So I end up with 25, and then that's going to be minus 4 times a negative 1 because I squared is equal to a negative 1. And so I get 25. A negative 4 times a negative 1 is a positive 4. So I just get 29. So the answer is just 29. Okay, number 9. Number 9, you have, number 9, you have 4 plus 3i squared. 4 plus 3i squared. Well, remember, 4 plus 3i squared, a binomial squared, means 4 plus 3i times 4 plus 3i. And that's the way you need to write it first. Because if you don't, you're going to say 4 squared is 16, and then 3i squared is 9i squared, and that's not correct because you're going to miss the out and the inner. You're missing the out and the inner. So don't make that mistake. Write it out. That's what you need to be doing. Okay, now, using FOIL, because those are two binomials, 4 times 4 is 16. The outer is 12i. And notice that since these two binomials are the same, it should happen that the outer and the inner should be the same. So notice the outer is 12i. The inner, 3i times 4, is also 12i. All right, now be careful with the last. So a positive 3 times a positive 3 is a positive 9. I times I is I squared. Okay, using the fact that I squared equals a negative 1, and using the fact that these out and the inner terms I can combine, I get 16, 12i, and another 12i is a 24i. And this becomes plus 9 times negative 1, because that's what I squared equals. So this right here becomes negative 9. So 16 and a negative 9 is 7. And then plus 24i. So 7 plus 24i, so there's your answer. Number 9 is 7 plus 24i. Okay, number 10. Number 10, you have 7 minus 5i squared. So the same thing as with number 9. Again, don't square the 7 and square the negative 5i. Square negative 5i, and then you're done. You got to remember there's also an out and an inner you got to deal with. So you got to write out what this means. This means 7 minus 5i times 7 minus 5i. And now you notice I have to use the FOIL method. So 7 times 7 is 49. So the first times first is 49. The outer, the outside terms, so 7 times a negative 5i is a negative 35i. Now remember, since these are both the same factors, the out and the inner should be the same as well. Negative 5i times 7 is also a negative 35i. See, these have to be the same. These two terms have to be the same. Okay, now the last. A negative 5 times a negative 5 is a positive 25. I times I is I squared. And remember, you got to remember the fact that I squared equals a negative 1. So I get 49. A negative 35i and another negative 35i is a negative 70i. And then plus 25 times a negative 1, because that's what I squared equals. So I get 49 minus 70i, and a positive 25 times a negative 1 is a negative 25. So I get 49 minus 25 is 24 minus 70i. So there's your answer for number 10. So number 10 is 24 minus 70i. Okay, now number 11. And now number 11, you have to show the work. So these you did not have to show the work, but you did have to do some work to get those. You know, notice how much work was involved. So you did have to do that. But here I need for you to show the work. Okay, so let's talk about some stuff here. So remember, you want to divide. You want to divide these. Now, you don't want the imaginary unit I in the denominator. So to do that, to get rid of this, just like you dealt with rationalizing the denominator, when you had an irrational number in the denominator, do the same thing here. So you can do that. You're going to multiply the numerator and the denominator by the conjugate of the denominator. So the conjugate of 4 minus I is 4 plus I. So you multiply both the numerator and the denominator by the conjugate. All right, so here when you multiply, and I guess, well, I'm going to try and do the work here. So because I do require you to do the work on this page. So notice that this is a monomial times a binomial, so you can distribute. You can distribute this. So I get 5 times 4 is 20, plus 5 times I is 5I, over. Now over here, I'm going to multiply these out using the FOIL method. Now remember, we talked about the fact that when you multiply conjugates, the out and the inner cancel. So notice 4I and a negative 4I. So when you add them, you get 0. So all you're doing is looking at the first. 4 times 4 is 16. And then the last. So a negative I times a positive I is a negative I squared. That's what you get, because the outer and the inner cancel, because those are conjugates. So then I get 20 plus 5I divided by 16 minus I squared, remember, is a negative 1. So this right here becomes 17. 16 subtract negative 1 means 16 plus the opposite of negative 1, which is 1. So I get, so this becomes 20 plus 5I divided by 17. Now remember, you got to write it in standard form. So the answer is going to be 20 over 17 plus 5I divided by 17. That's a 17. So there's your answer. Okay, over here, again, you're going to multiply numerator and denominator by the conjugate, because you notice I no longer had an I in the denominator. So you're going to do the same thing here. So you're going to multiply both the numerator and the denominator by the conjugate of 3 plus I. The conjugate of 3 plus I is 3 minus I. So you multiply both numerator and the denominator by that. Now this is a monomial, so all you're going to do is distribute this when you multiply the numerators together. So 7I times 3 is 21I. 7I times a negative I is a negative 7I squared. So 7I times a negative I is a negative 7I squared. All over. Now remember, those are conjugates, so when you do the outer is negative 3I, the inner is a positive 3I. When you add them up, those cancel. They should always cancel. So you're left with the first, 3 times 3 is 9, and the last, a positive I times a negative I is a negative I squared. Okay, knowing that I squared is a negative 1, I'm going to get, same thing here, negative 1. So I'm going to get 21 minus 7 times a negative 1, because I squared is a negative 1, divided by 9 minus a negative 1. So I had I squared listed twice, so I'm going to put negative 1s in their places. So this becomes 21, I'm sorry, this is 21I. So this becomes 21I, a negative 7 times a negative 1 is a positive 7, over 9 minus a negative 1 means 9 plus 1, so that's 10. And I'm going to get 21I over 10 plus 7 over 10, but I got to write it in standard form. So I've got to put the real part first. So that's 7/10 plus 21I over 10. So there's the answer there. Okay, number 13. So again, I'm going to multiply the, I have an I in the denominator, imaginary unit in the denominator, so I need to get rid of that I. So you're going to multiply, to do that, you're going to multiply both the numerator and the denominator by the conjugate of the denominator. So the conjugate of 2 plus 3I is 2 minus 3I. 2 minus 3I. Okay, so the numerator is a monomial times a binomial, so you can distribute. So I'm going to get negative 5I times 2 is a negative 10I. Negative 5I times a negative 3I. So negative 5 times a negative 3 is a positive 15. I times I is I squared. Okay, so that's what it gets so far in the numerator. The denominator, those are conjugates. So think about the outer and the inner. The outer is 2 times negative 3I is negative 6I. The inner is the opposite. So when you add them up, you get 0. That's always going to happen when we deal with conjugates. So you just got to look at the first. 2 times 2 is 4. And then the last, a positive 3I times a negative 3I. A positive 3 times a negative 3 is a negative 9. I times I is I squared. And so you got to remember the fact that I squared is equal to negative 1, so we got to rewrite these. So I get negative 10I plus 15 times a negative 1 divided by 4 minus 9 times a negative 1. So I get negative 10I minus 15 divided by, this becomes 4 plus 9. So that becomes negative 10I minus 15 divided by 9 plus 4 is 13. So writing it in the form a plus bi, two separate fractions, I'm going to get negative 15 over 13 minus 10I over 13. So that'll be your answer. Okay, now this one is going to be a little bit more involved because this time you have a binomial in the numerator. The others were just monomials, so I could have just used a distributive property, and that's what I did here. Okay, so again, though, still you want to get rid of that imaginary unit that's in the denominator. So you're going to do that, you're going to multiply both the numerator and the denominator by the conjugate of the denominator. So the conjugate of 3 plus 4i is 3 minus 4i. 3 minus 4i. So what you'll do to the numerator, I got to do to the denominator. So now I have to use the FOIL method. Now, this is going to be a little bit more involved, so I'm going to try and write it a little bit smaller here to fit it. Okay, so FOIL. 4 times 3 is 12. Now, be careful. Don't say, remember I'm dealing with the numerators, don't say that the outer and the inner cancel. That's not true, because those are not conjugates. These are conjugates of the denominator. So remember, the outer and the inner cancel if you have conjugates, so that's going to be the denominator. The numerator, those are not conjugates, so you got to be careful. So let's look at the outer. The outer, in terms of the outside, these two here, 4 times a negative 4i is a negative 16i. The inner, negative 3 times 3 is a negative 9i. All right, now the last. A negative 3, so here's your last terms. A negative 3 times a negative 4 is a positive 12. I times I is I squared. All over, all right, now let's do the denominator. The denominator, those are conjugates, so the outer and the inner will cancel. So all I got to do is look at the first, 3 times 3, which is 9, and the last, a positive 4 times a negative, positive 4i times a negative 4i, so positive 4 times a negative 4 is a negative 16, and I times I is I squared. So wherever you see an I squared, though, I got to remember to rewrite as negative 1. And I can combine these two terms here. So this becomes 12, a negative 16, I, and a negative 9i is a negative 25i, and then that becomes plus 12 times a negative 1. All over 9 minus 16 times a negative 1. Okay, I squared is a negative 1. So then I get 12 minus 25i, a positive 12 times a negative 1 is a negative 12, all over 9, a negative 16 times a negative 1 is a positive 16. So the numerator, the 12s cancel out, and you're left with negative 25i. And the denominator, 9 plus 16 is 25. Reducing, this just becomes negative I. So there's your answer, negative I. Okay, now, number 15. Okay, so you got to remember that the square root of a negative number is that imaginary unit, and the square root of 9 is just 3. So this right here, I'm going to go ahead and do the work, because it didn't say show work here. It didn't say anything about showing work. So I'm just going to go ahead and show the work on another sheet of paper. So number 15, you have 6 square root of a negative 9 plus 2 square root of a negative 16. All right, so we know that the square root of negative 9 is 3i, and we know that the square root of negative 16, so that's 2 times the square root of negative 16 is 4i. And so 6 times 3i is 18i, and then 2 times 4i is 8i, and then when I add them up, I get 26i. So that's your answer there. So number 15 is 26i. Okay, number 16, you have 4 square root of a negative 18 plus 3 square root of a negative 8. All right, now here you are taking the square root of a negative 9, and remember the square root of a negative 9 you can write as the square root of a negative 1 times the square root of 9. And the square root of a negative 1 is I, and the square root of 9 is 3, and so that's how we got 3i here. So for these, though, and this was easy because 9 was a perfect square. Now here, when I do this, square root of a negative 18, I get square root of a negative 1 times the square root of 18. Now notice 18 is not a perfect square, but you want to ask yourself, is there a perfect square other than 1 that goes into 18? And the answer is yes, it's 9. 9 is a perfect square that goes into 18. So you're going to rewrite this as negative square root of a negative 1 times the square root of 9 times 2, because 9 times 2 is 18. And then this becomes square root of negative 1 times the square root of 9 times the square root of 2. And the square root of negative 1 is I, the square root of 9 is 3, and you're just left with the square root of 2. But notice that we put the I between the 3 and the square root. So this becomes 3i square root of 2. So 3i square root of 2. So that's what the square root of negative 18 is. So this becomes 4 times 3i square root of 2. Then we do the same thing with the square root of negative 8. So let's do the work there. So the square root of a negative 8 is the square root of a negative 1 times the square root of 8. And you ask yourself, no, 8's not a perfect square, but is there a perfect square other than 1 that goes into 8? And the answer is yes, 4. So I can write this as square root of a negative 1 times the square root of 4 times 2. And remember, the square root of 4 times 2 is the same thing as the square root of 4 times the square root of 2. Square root of 4. So this becomes I, this times, and this becomes 2. And I can't do anything with square root of 2, so this is 2i square root of 2. So that's what square root of negative 8 is, 2i square root of 2. So I'm going to write this as plus 3 times 2i square root of 2. And now I notice that 4 times 3 is 12, so that becomes 12i square root of 2. And over here, 3 times 2 is 6, so that becomes 6i square root of 2. And notice that these two terms here are like terms. They both contain I square root of 2, I square root of 2. So there's 12 of them here, and then 6 of them here. So that's I square root of 2. So there's 12 here, and 6 here. So that becomes 18I square root of 2. So that's answer number 16, 18I square root of 2. Okay, number 17. Number 17, you have 4 minus the square root of negative 27 divided by 12. So again, just like you did this, you want to try and simplify the square root of negative 27. So let's kind of figure out what that is. Square root of negative 27. So that becomes the square root of negative 1 times the square root of 27. Now we all know that 27 is not a perfect square, but other than 1, the other perfect square, the largest one that goes into 27 is 9. So I can write this as square root of negative 1 times the square root of 9 times 3. So it becomes square root of negative 1 times the square root of 9 times the square root of 3. And so the square root of negative 1 is I, square root of 9 is 3, and I'm left with the square root of 3. So this becomes 3i square root of 3. So that's going to go here. So this becomes 4 minus 3i square root of 3 all over 12. Okay, now remember the direction says to write it in standard form. So I'm going to rewrite this in two fractions. So I'm going to get 4 over 12 minus 3i square root of 3 over 12. And then I'm going to reduce. So 4/12, so we've got to reduce. So 4/12, 4 goes into 4 1, 4 goes into 12 3 times, 3 goes into 3 1, 3 goes into 12 4 times. So then I get as an answer, I'm going to get 1/3 minus I square root of 3 over 4. So that's your answer for number 17. So 17 is 1/3 minus I square root of 3 divided by 4. Okay, number 18. 18, you have, I'm trying to get a piece of paper. Okay, 18, you're going to have, all right, 18. You have negative 6 plus the square root of negative 24 over 24. Alright, so again, just like we did the others, you're going to figure out what the square root of negative 24 is. So the square root of negative 24 can be written as the square root of negative 1 times the square root of 24. And you ask yourself, is there a perfect square other than one that goes into 24? And you always want to pick the largest. And so the largest would be, let's see, 4 times 8 is 24. Let's see, 4 times 8 is 32. So 4 times 6 is 24, so I can use 4. So that's the square root of negative 1 times the square root of 4 times 6. And so square root of negative 1 times the square root of 4 times the square root of 6. And square root of negative 1 is I. Square root of 4 is 2. Square root of 6. And so this becomes 2I square root of 6. And so that's what goes here. So I get negative 6 plus 2I square root of 6 all over 24. Now remember the direction set's right in standard form. So this becomes negative 6 over 24 plus 2I square root of 6 over 24. And then all you do is reduce. So when I reduce, 6 and 6 is 1, 6 and 24 is 4, 2 and 2 is 1, 2 and 24 is 12. And so the answer is negative 1/4 plus I square root of 6 over 12. So that's answer number 17. So 17 will be negative 1/4 plus I square root of 6 over 12. Okay, so that one was a pretty involved worksheet. There's quite a bit of work you have to do with those, and you could easily mess up, so you got to be careful. So learn from here which mistakes are for the test. Alright, so that's going to take care of this worksheet on section 1.4, section 1.4, part 1.